I'm back in the room. We can start with the afternoon session. As I mentioned this morning, we have now my presentation on the techno-economic view of the future of telecommunication, the white paper that we have published in April. We will have another version at the end of this year. And then we will have a panel discussion with some guests that I will introduce later after this presentation. So let me start just mentioning that this work has been done with a pretty large team of people from Politecnico di Milano, but also Nicola and other people involved in this activity, and also that the Net for Future project collaborated, and we are also continuing to collaborate for trying to put together, the future scenarios that they have elaborated with you, with the scenarios that we describe in the white paper. So what was and what is still our goal? So our goal is that not trying to predict the future, but try to understand what are the elements, the factors that can influence the future and help decision makers to take decisions based on the possible path that can bring us to these possible futures. So that's the goal of technology and strategic foresight, and the approach that we have been using is an approach which is a little bit original because we have put at the center technology, but we also try to understand how technology is influenced by the ecosystem a balance that we can create. The horizon that we have been considering is that of Europe, of course, with a special focus on the Italian market. We started describing the new ecosystem model as a proposal that we did for better understanding, what is changed and what can influence the future evolution. And then, this version of the white paper described the potential evolutionary scenarios that we have elaborated with your help. And the last step will be that of adding to the model a quantitative analysis that can help decision makers and also market players to understand how moving the balance to a different equilibrium point can lead value to the entire ecosystem and their specific companies. Let me start trying to describe, the analysis that we did of the current situation and the type of ecosystem that we have analyzed. If we can look back a few years ago at the value chain, the old value chain of telecommunications, we should have probably described it more or less like this, with a chain, a linear set of relations between players, relations that were basically one monodirectional client and customer and service point of view, and with a way of using the relations that were mainly centered into the role of the telco operators. So the telco operators were at the center of this system, buying services and equipment and providing services to the end users, with the help, of course, of some service development and service delivery companies. The world is changed, and the world is changed for a number of reasons. So what we have done is trying to describe a new architecture, and as usual in our domain, we use a layered architecture. A layered, of course, not because of the protocols, communication protocols that we are used in telecommunications, but because of the relations between different activities that are done by the market players for creating values in this ecosystem. This is a representation of all the big activities that can be done in this ecosystem, even if we have a much more detailed structure describing individual specific actions that are done by the different market players trying to capture the value generated by the ecosystem, from the backbone infrastructure up to the vertical enabled applications. Of course, I will not go into all these little activities, but you need to know that the description of the ecosystem based on this model can describe the role of the different players, listing and understanding the value of the different activities they do and propose to the market. And of course, this is just one step. The second step is that of mapping the relations between players. Mapping the relations between players means that we no longer have the telco operator at the center of the scene, but we have a network of relations where we have, of course, a different perspective in terms of how these activities, how these players can interact with each other and generate value. The reason why we have this is because of a number of different things that have changed with respect to the past. We have an increased complexity in the relationships. We have the big crisis of the vertically integrated operators. We have more advanced services which require radically different activities done on the market for bringing the services to the end customers. We have a platform model which is radically changing the way we do business in telecommunications. This is something that happened already in many other markets, including the cloud market, where platforms are dominating the economy generated by the applications and the data centers and the cloud services. And probably this is the historical period in which we will see this transformation also for the telecommunication ecosystem. And also we have a number of newcomers from other industries that are trying to steal some of the values of this ecosystem for their business. Of course, there are many challenges that can influence the evolution of this ecosystem, but one of the key questions that we need to try to answer is how can we protect the value and possibly enlarge the value of this ecosystem, trying to capture values which is now in adjacent sectors related to digital economy. And this is just for taking a snapshot of this current situation. If we now start looking at the future, there are a number of different things that are influencing the continuous evolution of the system. And a number of questions that we need to answer in order to understand which direction can the system take. What kind of relations will be created? How can the different players take advantage from technology innovation? How this new balance will redistribute the value among the players? How can this value be increased, and which of the actors will benefit from it? And moreover, what are the possible strategies for expanding the market to different sectors and trying to create value from the possible synergies with other markets? This was the starting point for defining the possible future scenarios. And the possible future scenarios, of course, can be created only with the collaborative work that we did with your help, with also secondary sources in discussing with many experts, with a co-creation workshop that we did together. This was a huge effort that then we tried to synthesize in a set of diagrams. So all the details are in the white paper if you want to look at the details, but we mapped a very large number of evolution trends, 75, which we tried to summarize in 16 megatrends. And based on these 16 megatrends that we tried to put together in a coherent way, we defined 4 possible future scenarios. These 4 possible future scenarios, of course, are ways of describing the space of possible futures. And describing the space of possible futures means that we try to bring to the extreme some of the variables and try to delimitate the space of possibilities. So you don't have to take these future scenarios as something that a set of fixed options that you can just pick one and understand how the future will look like. They are somehow ways of delimiting a space that will probably be the one that will be enabled by the decisions that we will take in the next future. Of course, one of the most interesting things is understanding in this space which is the space of preferable scenarios, those that can, for example, rebring Europe at a competitive level, which is at least comparable to that of US and China. This is the map of the megatrends that we selected. Of course, not all the names are so representative, honestly, because it was a little bit complicated to give informative names that were not too long to all the megatrends. But the idea is that we really try to consider both technological changes and also business changes. And also we try to map a number of wildcards. Again, this is something that is common in foresight exercises. One is, of course, spectrum policies is something that still we don't know for the next future, for example, for 6G, we discussed this morning. But there are also important initiatives that are trying to get the support at European level. One of these is the European Cloud and AI Consortium, and we will have later during the panel a presentation of Cristina Caffaro regarding Eurostack. Again, also this was mentioned this morning. I will now briefly present you the 4 scenarios. Again, don't look at them as like options, but as ways of delimiting the space of possible futures. And I will be using 4 descriptive variables: the market structure, regulations, technological innovations, and ecosystem protection, which are not necessarily specific variables. These are kind of ways of describing the scenario. In the white paper, you can find the variables that we have considered, not only for describing the scenarios, but also trying to understand the impact on some of the KPIs that you typically consider to understand how suitable or how preferable is that scenario, considering what you want to achieve in terms of value created at European level. So the first scenario, scenario A, is what we call slow evolution with telco commoditization. Commoditization is a very bad word, but just to try to explain that this is the scenario where things don't change much from the current situation. So we continue with the extreme competition among the market players. The value of the connectivity continues to go down, perceived by the users. Again, we discussed already this morning in some of the presentations. And we continue with the difficulties in sustaining investments in the infrastructure. Of course, this looks like a kind of temporal loop. We stay in this equilibrium. This is not like this. Of course, if you stay still, basically things get to worst. And this is important to understand, because the not taking a decision is taking a decision. And this is important because if you don't change anything, things can get worse. From the technological point of view, this means that basically global players will continue to have the lead, and the European player will continue to be the followers, extracting little value from technology innovation, starting from AI, cloud, and cybersecurity. The network platforms, this is something that is a technology trend that we will continue to discuss during this workshop. Will probably cannot be stopped, because the transition toward the platform economy is something that we cannot stop. But controlling the platforms, this is important, and probably in this kind of ecosystem, the platform will be controlled by non-European players. This means that from a regulatory point of view, we will have a lack of a real single market and a fragmented regulation, more or less like we have now. And from the European protection point of view, we will not probably protect much the European ecosystem, and we will continue to be weak at international level. Not very suitable perspective, but this is something that at the moment is where we are going if we don't do anything. The second one is the scenario where probably most of the market players are looking at, right? The idea is that we try to go in the direction of the single European market, and also to provide some service platform for trying to capture some value. But this is done in a way which is considered relatively straightforward from the market players, in particular market consolidation, so a reduction in the number of European operators that we have. This is already happening, as you know, in Italy, but also in other countries. We have at the moment 35 operators in Europe, if I'm not wrong, reducing of 1 or 2 probably will not change too much the situation, honestly. Of course, this will increase a little bit the possibility of making investments, because of course this will optimize cost, but on the other side will not change the landscape. From the technology point of view, of course, having more money means that you can play a better role in trying to take advantage of innovation. But of course, this will be done in the way we already know, which is the dominating one, for example, in other markets, including North America and Far East. From the regulation point of view, we still need to see if these merges among telco operators will be allowed by the European regulators, in particular the big merges, not the little ones that we already had, which means that somehow we expect some relaxation of the antitrust rules. And from the protection point of view, this is something that will probably allow a better competition, but without changing dramatically the equilibrium with respect to North America and China. Scenario C is a scenario a little bit more disruptive. The idea is that we will have the rise of infrastructure providers, not only vertically integrated operators merged at the European level maybe, but also with some separation of infrastructure and services and new platforms. New platforms because, of course, the separation can stimulate the rise of new platforms. The idea is that, of course, we will not only have merges, but also separations of service and network infrastructure, like happened for different reasons in Italy with TIM and FiberCop, of course. This, of course, is something that need to be allowed by regulation at the European level, because, of course, you need a number of rules for regulating the wholesale markets. And of course, this can stimulate a different approach to managing the industrial strategy in our sector. One of the components that we believe can enter into the game in this scenario is a strong support by European institutions of this European Consortium of Cloud and AI, because this can be a real game changer in terms of enabling the European players to take advantage of the value created by the ecosystem. Of course, this creation of this platform can create value by itself, stimulating new players to create applications on this platform, to generate a more robust growth of the network as a service market, and the development of advanced digital services that are developed and run in Europe. And of course, this will be translated probably in a greater protection of the European ecosystem by European authorities. This will for sure reduce the gap from US and China, but also will start allowing Europe to play a different game. A different game, which is basically what we envision in the last scenario, which is scenario D, with a full infrastructure separation and shared platform. The idea is that basically in this scenario, we really try to follow the disruptive changes of technology in the direction of the creation of platforms, digital twins, digital services on network platforms, which are distributed platforms, not concentrated or centralized platforms like those of the cloud. And this can really create an ecosystem which is radically different from other markets. So the idea in scenario D is that Europe can decide to play a different game from North America and China. Of course, this should really be supported at the regulatory level, which of course doesn't mean that you force the system in this direction. It's a mix of industrial strategies and regulation, of course. And finally, of course, this means that from a political point of view, we really have the goal of trying to protect for at least for some time the European ecosystem and trying to regain competitivity, playing a different game, and trying to be stronger into the global market before, you know, somehow coming to some compromise with the rest of the world. So that's the idea. This is, you know, the big picture with all the scenarios and all the main variables. These are again what we have derived from the discussions with you and players, but you know, of course, this is an ongoing work. You can criticize the work, you can add new things, you can give contributions. We are open, and we will continue to work until the end of December for trying to finalize the last version of the white paper and trying to really provide an instrument that can be useful for our institutions and market players. We have many open questions. What will be the scenario that which will give more competitiveness to the European ecosystem? What are the strategic decisions that are more in line with what we expect for the future? What are the risks in relying only on market forces instead of trying to have a strong industrial strategy? And what is the consequence? What are the consequences and possible opportunities also deriving from the tariff crisis and the, you know, not let's say difficult relations that we have now with US. So I stop here and thank you for your attention. And now we will start with the panel. Thank you. So we have the pleasure to have with us Tullio Ambrosone, Single Market Lab. Tullio, can please come here. Marzia Minossi, Astel, Asso Telecomunicazioni. And by remote, we have Cristina Caffarra, Eurostack. Cristina, can you hear us? Just to be sure that the connection is okay. And we also have connected by remote Alessandro Goppelli, Connect Europe. I hope the connection is okay. Okay, great. So I see Cristina and probably also Alessandro is connected. Thank you. So we received a video contribution from Enrico Letta. So I kindly ask to put the video of Letta on.
Buongiorno, mi dispiace molto non poter dare se non un messaggio da remoto, da lontano, però mi fa molto piacere farlo perché quello che state facendo, quello di cui state discutendo è veramente centrale oggi. Io ho sempre pensato, nel momento nel quale ho cominciato a lavorare sul tema del rapporto sul futuro del mercato unico europeo, quando il Consiglio europeo mi dette questo incarico, dopo una prima panoramica, parlando con i diversi settori coinvolti e avendo individuato 3 settori chiave, telecom, energia e mercati finanziari, come i 3 settori nei quali il mercato unico alla fine non era e non è mercato unico, non è single market, ma sono alla fine 27 mercati separati. Ho sempre individuato quello delle TLC, quello delle telecomunicazioni, come il cosiddetto low hanging fruit, cioè la possibilità lì di ottenere dei risultati forse più rapidamente che negli altri settori. Risultati legati a che cosa? Innanzitutto legati all'integrazione del mercato. Siamo 27, non 1, e questo è un drammatico elemento di mancanza di competitività, perché riduce la dimensione delle imprese, rende le imprese tutte più affaticate e zoppicanti in un mercato globale in cui invece i giganti americani e cinesi, non solo americani e cinesi, ma quelli sono particolarmente grandi, giocano una partita praticamente di un altro campionato rispetto a noi. Questo perché il mercato delle TLC parlava europeo negli anni 80 e 90, quando ha visto il suo grande, diciamo, la sua grande esplosione, dopodiché noi siamo rimasti frammentati e gli altri sono cresciuti. Quindi c'è un tema consolidamento, un tema fondamentale. ovviamente con la necessaria protezione dei consumatori che deve andare di pari passo, ma se non c'è questo lavoro di crescita dimensionale, la capacità di essere innovativi e competitivi non va da nessuna parte. Aggiungo a tutto questo la vera novità. La vera novità è che oggi c'è una dimensione di sicurezza che è fondamentale. Questa dimensione di sicurezza ormai, purtroppo, con gli sconvolgimenti ai quali stiamo assistendo, necessita un legame tra la connettività e i principi di sicurezza, la necessità di sicurezza del nostro continente europeo, che fino ad oggi in verità non trova grandi risposte. Quindi anche in questo c'è un grande investimento da fare in termini di innovazione e anche in termini di qualità e in fondo anche di dimensione. In questo senso ritengo, ho sempre detto che questo tema e questi settori fossero il low hanging fruit. Spero che sia così, cioè spero che la Commissione faccia passi avanti importanti nelle prossime settimane, nei prossimi mesi. Spero che i Paesi membri non si mettano di traverso, spero che le imprese siano in grado di vivere questa vicenda con l'investimento che è necessario. Io penso seriamente che sia ora o mai più per questo settore, dopo anni nei quali in fondo la situazione è andata drammaticamente declinando. Oggi abbiamo bisogno, dal punto di vista della competitività delle imprese, di cogliere questo momento. Se non lo faremo, poi sarà peggio anche per i consumatori, che magari oggi sono contenti, ma di fronte a un sistema industriale europeo così depresso, finiranno poi per pagare loro il conto successivamente. Penso che questo obiettivo e gli obiettivi che sono contenuti nel rapporto e nel rapporto Draghi possano trovare oggi tutte le condizioni e l'allineamento di pianeti per riuscire a essere ottenuti. Bisogna farlo e bisogna farlo con grande determinazione. Questo è l'impegno che ci stiamo mettendo, che ci sto mettendo anch'io per quello che posso, per quello che la mia voce ha senso, possa farsi sentire. La costruzione dell'area del Single Market Lab, il lavoro di network con le università europee con cui stiamo lavorando per rendere questi messaggi forti e ovviamente una fortissima compartecipazione e condivisione con il sistema delle imprese, che ha più interesse a far sì che questi passi avanti in termini di modernità e di competitività siano effettivamente quelli nella giusta direzione. Credo che questo sia il tema principale, questo è sicuramente il tema e gli obiettivi che io sto cercando di raggiungere.
Thank you. So I take advantage of the video that Rigoletto sent us to start with Tullio Ambrosone, Single Market Lab. What are you doing in the lab and what are the goals that you are trying to achieve?
Thank you, Professor Capone, first of all, for this opportunity, and I'm going to try to expand a bit the reflection that Ricoletta was making in the video and position the discussion that we are having today in the larger scenario that we have around us. And I'll start, before getting to what we are doing with the Single Market Lab, by picking up on what Ricoletta was saying at the beginning of his speech. The fact that today we cannot speak about a real European telecom market. When you talk about telecom markets in Europe, we still have 27 fragmented markets. And this today is the strongest strategic vulnerability that the sector has. Of course, there is a reason why we are here today. 30 years ago, when the single market was created, we decided to keep aside the specific sector like telecom, because they were considered too strategic to be passed on to the European supranational dimension. And that made sense in the 90s, when European economies were at the center of the world economy, when intra-European competition was the real engine of our growth and of our competitiveness. Today, 30 years after that milestone, we are in a completely different scenario. Competition is coming from abroad, competition is fierce, competition is aggressive. We have large economic giants around us that are putting us under pressure. And the scale gap that we have today, due to this fragmentation, as I was saying, is really the vulnerability that we are facing. And this vulnerability takes several different positions. Let's say it's an industrial vulnerability, it's a security vulnerability. So this is really the problem we are facing today and the starting point for the reflection. We could look at many different indicators, and looking at the industry, take, for example, the top 10 telecom operators in the world. The only European company in that index is Deutsche Telekom, the Germans, mainly because they have invested in the United States. The next European operators are far down the index. So just this to give an example to prove why the situation is problematic. And there is another example that is quite emblematic. The fact that 30 years ago we were launching GSM. It was us, the European, at the pinnacle of innovation, launching digital infrastructure standards. Today we are having difficulties in deploying all across the European Union with speed and consistency 5G networks. That is a technology that is coming from abroad. So the analysis of the scenario is quite clear across the sector, across the European Union, and also the direction we want to take, at least at the European Union level, is quite clear. We have the Letta report. There is also the Draghi report that has a specific important chapter on telecommunications. And of course, there are the plans of the European Commission, the white paper, but also what the European Commission is planning to do in the fall with the Digital Networks Act. The problem is that we have at the moment a mismatch between theory and practice, between what we know we have to do and what we are actually doing, especially the speed at which we are working. And this means at the end of the day that the main problem is not technical, it's rather political. And this is where somehow the Single Market Lab tries to give its contribution. This project, this Single Market Lab, was created by Enrico Letta after his presentation of the report on the future of the single market to follow up on the implementation process. It's a policy hub, it's a European network, as he was saying, of universities, of think tanks, of European businesses. And the aim of this network is to develop proposals and narratives, especially narratives, to support the implementation process. And in particular, when we talk about the telecom sector, this means, as the report on the future of the single market, there is a specific roadmap to get there. This means we have to create a more European telecom market. It means harmonized rules, it means integrated governance, and of course also consolidation. That does not mean mimicking other models like the Chinese or the Americans. It needs that we need to find our own way to get there, and it needs that we need to create the right market conditions in the industry to allow our companies to have the scale and depth to grow, to invest, and to compete at the global level. Because with the kind of technologies we're talking about the need of massive investments, and therefore we need the scale of the European market to get there. So as I was saying, the Single Market Lab works on proposals and on narratives. It does so both in the European level, in Brussels, working with the European institutions, but even more importantly, it does so in the national dimension. So it's a wide web of connections with think tanks, universities, and the idea is that the big part of the work is at member states level, is in the national dimension, because there is still this idea, and it's also there in the telecom sector, that economic integration and the creation of a true European single market in telecom means losing control, means losing sovereignty. What we try to say is exactly the opposite. Going in that direction means regaining control in a situation in which we are already losing it. And it's the international scenario that is kind of proving us that this is the case. So the Single Market Lab basically tries to bridge the gap between theory and practice by developing activities that are exactly aimed to this objective. And specifically on telecom, what we are trying to do, Enrico Letta mentioned it, is in terms of content, first of all, is try to overcome this political obstacle by connecting this narrative on the need to integrate the telecom single market with what is today the strongest catalyst of political engine. That is the need for security, the need for defense, and open strategic economy. As I was saying at the beginning, the situation in which we find ourselves today is a strategic vulnerability that has not only to do with the competitiveness of the industry, it has to do overall with the security of our continent and of our economy. Therefore, what we are trying to do, we are developing a report with specific proposals in a framework that can connect these two important aspects, integration in telecom and security, because we really believe that when we talk about economic integration and when we talk about the reforms that the European Union needs today, we need to position them in a broader framework in order to allow both the Commission and member states to get there. Because I was saying on many issues, we are talking about telecom today. In the single market, we talked about many different sectors like energy, like finance, pharma, transports. It's always the same problem. The problem is more political. So of course, we need to develop and continue to discuss about the technical aspects of all of these reforms. reforms, but there is this important other part in play that is related to the narrative built upon the technical vision that is there. And I conclude with a final reflection that has to do with the methodology of all of this. And this is what we do in the lab, but what is needed in Europe in general. Reforming the single market, reforming the telecom market is not a job for one president of the Commission, for one government. It's a collective responsibility. And exactly as was done at the establishment of the single market 30 years ago, we need to develop coalitions, we need to involve all stakeholders and work together towards this objective. I want to underline this aspect of collective responsibility. We are here today, I'm sharing with Marta, with Alessandro, but also with Cristina, people who are part of this operation somehow, and this just to underline really how also moments like these are important to put together the technical aspect with these political narratives that are crucial to get where we need to get. Thank you. I'll leave it at that for now.
Thank you. We will have the opportunity then to ask Tullio also questions later. Let me continue with Cristina Gaffarra. So you have a leading role in this initiative, Eurostack, which is not particularly well known, in particular in Italy. So can you introduce the initiative, better clarify what's the direction you are taking and what are the steps that are necessary to make it real?
Thank you so much, Antonio, and I hope you can hear me.
Yes, very well.
Very good. Again, I'm sorry not to be able to be there in person. I'll try to do my best to convey the message. I want to introduce the initiative, but perhaps a way to do so is to start from briefly introducing myself, because the journey that leads to the initiative for me and for many is linked to a personal and clear realization that what we were doing and what we've been doing is not enough. So my background is an antitrust economist. I've been involved in all of the cases that the European Commission, the national agencies, the US, other regulators have pursued in the digital space. So you think about all of the cases against Google, Facebook, cases against Apple, Amazon, and so on. And in that dimension, Europe has been certainly a pioneer, because it is since 2010 that Europe has started to pursue in Google, for example, and has pursued Google and concluded 3 cases pretty much against Google. What has become clear is that antitrust and regulation in this space are not delivering. And that is even before we factor into the mix the effect of President Trump and his current administration, which of course is scrambling the cards even further. The reason it doesn't deliver is because we are faced with players, with platforms, with enormous capabilities and strengths. We have moved too late. And certainly to be tinkering at the margin with some of their behavior, do not self-preference, do not refuse interoperability to this other player, is not going to change the competitive landscape in a meaningful way. So this realization has really motivated the reflection on what it is that Europe is doing. What is our future role in this entire digital ecosystem? The reality we are faced in at the moment, we are immersed in at the moment, is that we are a digital colony. Because while we have focused on trying to regulate what you can call the superficial level of the digital world, so the App Store, Google Search, Amazon e-commerce platform, there is a whole infrastructure on which that digital world essentially relies, which is connectivity, very relevant to this event, but also compute, of course, cloud, cables under the ground. Of course, there's a whole infrastructure that is practically not owned by Europeans. And when you realize this, the implications in terms of resilience, in terms of agency, in terms of sovereignty, in terms of geopolitical risk become very, very clear. We can regulate the App Store, but it does not change this fundamental reality. Even if the European Commission were able to regulate the App Store or Google Search, which they're not, This would not change the fundamental reality that our cloud industry in Europe is owned by 3 players, AWS, Google, and Microsoft. And when you do realize that, you ask yourself, well, what happened to the European digital industry? Europe was a pioneer, and certainly on a par with the US 20 years ago. We had incredible technology. We still have incredible assets, capabilities. Our software engineers are the best in the world. We have capabilities in cloud, in connectivity, and yet we are in a shrinking position as a digital cloud colony, which creates these dependencies that are absolutely intolerable for us as a continent. So the question really is, how can we motivate a shift in this? And I've listened with interest to the contributions of Enrico Letta and, of course, Tullio. The reality is that, again, the report of Enrico Letta and Mario Draghi have put very starkly what is the problem which is facing us, which is ultimately Europe's current economic and social contract is not sustainable going into the future. Our entire economic model, which is based on exporting fundamentally cars to China and the US, is not going to sustain us. It is essential that we power up key sectors, which are, of course, green tech, which are to do with defense, and indeed digital, with our own assets and capabilities. So this is not just a digital strategy issue. It's an industrial strategy problem, because we have, again, the capabilities and the means in Europe to resurrect a digital industry, except we don't. So what is missing in this scenario? Certainly, I concur. There is, of course, a question of political will. But I also think the Eurostack movement is very much, certainly the industrial or the industry initiative that I sort of lead is very much one in which the responsibility is also with industry. This cannot be a project which is led in Brussels at a desk by showering money across Europe, helicopter style. This is what the European Commission has done for the past decades. There's an issue, let's create a lump of money and throw it around in ways that are not necessarily conducive and productive to generate industrial capabilities. We all know what the shortcomings of this initiative are. They are money which is parceled up in small parcels, thrown to various actors in a way that is not capable of generating results. So we cannot just sit back and say, well, let's hope for the best that the European Commission will generate an industrial project. They will not, because they do not speak to industry enough. They're not led by industry enough. And same is true of member states. Member states can be problematic, but indeed there is the same question of lack of technical competences and knowledge at the level of decision making. So it is time for industry absolutely to rise up and say, we know what needs to be done. We need an industrial strategy that has these components. Much of it is also on us, because it's not okay to sit there and say, well, we are so fragmented, what can we do? It isn't the sole problem. American giants came into Europe and rolled out. Of course, they had the capital, but they rolled out from France to Germany to the UK to Italy, and the barriers didn't stop them. What I'm trying to say is that there is a lot of it that is on us. So we European tech capabilities need to design what the project needs to be and then seek ways of implementing it. Because to wait for Brussels in its wisdom to design the future of the digital industry at the desk for the next 20 years is absolutely insane, and we will not get anything out of it. So Eurostack tries to essentially motivate that kind of spirit in which industry needs to collaborate to come forward. We need, of course, help from initiatives like procurement. Because it is insane that if I speak to the European Commission, I speak to them on Microsoft Teams. Do we have no collaboration software in Europe? Of course we do, but we don't buy it. Why don't we buy it? A function of habit, of convenience, of relationship, of capture. So the public sector needs to be made to buy at least part of their requirement from European players, which have got many of the suitable functionalities, not all, of course not, but the European players also need to just put forward products that people want to buy, and this is on them. You cannot have the European Commission or the government design a product for you. This is what industry needs to do. So Eurostack seeks to push this kind of mindset out there. Thank you very much.
Companies, Marcia. So what can companies do and what they are doing? I mean, you started with a new presidency in Astel, and you identified some priorities. Can you tell us a little bit more?
Yes, sure. Can you hear me?
Yes.
Yes, sure. The new presidency indeed will work on the items that we focused on as lever for the Italian telcos development, for the telecom industry development. First of all, let me explain that Astel, which I'm in charge of regulatory area, is the business association in Confindustria for the telco industry. So we represent on a general basis, I mean, on those issues that are common, both operators, well, not only operators, but the whole value chain. So vendors, operators, customer relationship management, tower cos, wholesaler, all the value chain of the telco in Italy, the telco industry in Italy is represented by Astel in the in the system of Confindustria. And so we are very sensitive to all the issues that have been raised up till now, of course, of a national basis. Although working on a national basis brings us to work on the European dossier as well, because things are indeed very linked, although the single market, as they said, is not yet complete, let's say, you know. And this is a kind of problem in the way, in the first of the items we are working on, and the first of the problems that we have focused on as something that's keeping back the telco industry, that is the difference in the rules that goes against the telco industry in comparison to those other kind of market actors that have been cited as well. And of course, the first idea that comes to mind is the over the top, so the big giants. But it's not only referring to the big giants. Indeed, there is need for a review of telco rules comes from a deep evolution that the sector is experiencing. And I think that your presentation, Antonio, has been quite explicative of this evolution, because from the old monopoly, we have gone very, very far, and now we have also a fragmented telecom industry in the way that, in the sense that each operator has different choices to focus on different strategies to address the market, and so just to refer to the last year, we have seen one operator that choose to divide network and services, let's say so. It's not completely so, but for sake of simplification. But then another operator has gone to work on consolidation of fixed and wireless services, because when we look at the merger of Fastweb plus Vodafone, we see that Fastweb was more focused on fixed network services. Vodafone surely has been the opener of the market in the mobile industry, and they have come together now. So from a strategic point of view, we see that different strategies coexist now, and they coexist now because indeed we are at the point that Antonio showed before. We must understand this big evolution, where is it going? And we must start from where are we now? And now we are in difficulties, I would say great difficulties, but anyway, some kind of difficulties, because the economic fundamentals of the market are not that good. I mean, for the Italian market, we have seen a decrease in revenues that accounts for 15 billion euros in 13 years. That's a huge amount of loss of revenue. And in the same period, we have had an amount of investments in networks that is above 85 billion euros. And these investments have produced a raise in data traffic that it's incremental, and it's astonishing, I would say, if it was not data, but it were some kind of other kind of products. So, of course, these fundamentals are not fitting that well together. So the economic sustainability of the sector in Italy raises some worries. But these trends have been more or less the same in Europe. And this is why we start from a point where really there is a sense of urgency in the industry about reshaping the rules as well as the market is reshaping itself, and as well as innovation is going on and is producing its effects also on the way the services are produced and engineered. So this is also one the reason why Astel is supporting Restart, because as we have seen, Restart is going deeply in this in the consequences of innovation on the market and on the strategies for the sector. And of course, as being the sector representative for the industry, Astel is interested in understanding where the sector is going, and of course to understanding where the sector is going, but also helping to build the best framework to regain development, to regain a raise in revenues, and to regain a solid health for the industry. And it's also a general interest item, because of course we are talking about telco industries and electronic communication services, but we must always remember that electronic communication networks and services are the base for the digitization of the whole industry, of the whole economy. And digitalization of the economy is one of the priority of the any kind of political plan you can look at. If you look at the PNRR, if you look at the Digital Compass, or in general the communications from the European Commission. So, of course, this is an industry issue. I mean, to regain, to add value to this baseline, I would say, of digital services is an industry issue, but is as well a common issue. So it's important to work on those levers that can help us to have a better future, let's say. And as I said, the first one is our rules, is the review, and it's starting now. So with this sense of urgency, but then there are other production factors that needs to be taken in account, and that is still lacking. One of these is energy consumption, and the energy costs are a problem, I would say, anyway, are worrying, because of course networks and services works with the energy, and we all know what the energy markets are experimenting. They have become unpredictable, and this is the real problem. And then there is, of course, the issue about the frequencies. especially about the cost that in Italy we have experienced for using the frequencies. The last allocation for the 5G has been the most expensive in Europe. So, of course, it somehow has drained resources for active investments on the networks. And of course, in general, infrastructure development has always been an item that we have always worked on in a very detailed way. And this leads us to talk about local community role, because local community have a big role in helping to develop the infrastructure, but then somehow the relationship becomes a bit difficult because, of course, not always the objectives are common and in the same time. So I would say that from an industrial point of view, these are the main items we are working on. These are our priorities also with the new president. And then, of course, there are the so-called soft skill. We also, as association, we have a big job to do, and we have done a lot already on underpinning the need for reskilling, upskilling of people working in the sector, because the digitalization is a challenge not only for those industries that we call verticals, but are a challenge also for telcos as well. So skill and labor rules are another big part of our job. And another focus, also because it's part of the association, is on the customer relationship management sector, because of course this is a sector that has specific issues, but it's very important because it's the forefront to the customers, to consumers in particular. And so this is also an area that we are really interested in. And it poses challenges as well. I mean, any of us is usually called by spoofed numbers, and this is on the forefront. I mean, telco operators are on the forefront of combating the spoofing, because it brings everyone to lower the value of this contact that we can have also with other kind of services. And it's of course a problem, because it is anyway an industrial activity and people are working on it, and we can have good value also from that kind of activity if it's done in a legal framework in a correct way. So this is overall what we are working on.
Thank you, Marcia. Coming to Alessandro Coppelli, Connect Europe. Alessandro, Connect Europe has been particularly active in trying to raise the awareness of this current situation and its unsustainability for the European ecosystem. How do you see all these initiatives, and how can they be aligned to the wheels of the different companies in this market, which are not always perfectly aligned, honestly?
Thank you, Antonio, and thank you for your paper, which is very thought-provoking. Connect Europe represents all the main European telecom operators in Brussels. Let me start from a thing which I'm repeating a lot lately, and I don't know if it would make Mr. Letta and his team happy, or Mr. Draghi and their team happy, but what I'm explaining here in Brussels is Italy has a lot of authors, some more esteemed than others, like Letta and Draghi. And one other author that we have is Tomasi di Lampedusa, who wrote The Leopard. And the most famous line of The Leopard is that everything must change for everything to remain the same. My fear right now in Brussels is that we risk that the Letta and Draghi report are used by the establishment to do the Leopard. So to say that we want to change everything, but then not to change in concrete terms. This is maybe an opening joke, but I'm very convinced that right now, as also Tullio was saying before, there are so many good reasons to go about and implement the Letta report and the follow-up of the Draghi report. There is a sense of urgency, and also there is a sense of the opportunity that we can grasp ahead of us. Listening both at your presentation as Politecnico, but also at the interventions that came before me, I tend to agree that we are losing control, or we risk losing control also of this layer of the European technology stack, which is connectivity. But there we still have a chance to keep hold of it and to flip the situation towards a leadership one. And probably the important or the key technologies that we should focus on are those around the cloud and edge cloud, but also network virtualization, because as you explained, we are virtualizing the network. So even in a virtualized and cloudified scenario, we should keep hold of those networks, but also of all the value added that will be developed on top of those networks, so that we don't repeat the problem that we have seen in the past 10 years, in which we invested a lot into the networks, but this investment has been monetized by others. This requires change, and it requires the real change that we read about in the Draghi report and in the Letta report, and not the fake change that you can find in the beautiful book of Tomasi di Lampedusa. What is this real change about? The first one is the acknowledgement of the topic of scale. It came back in different ways throughout your report, Antonio, but also in the interventions before. How can we think that 100 small operators can sit down at a table with a big tech player to negotiate a cloud deal, or to negotiate smartphones in their shops on equal terms, when your market capitalization is maybe 1 billion euro, and in front of you there is somebody with a market capitalization of $1 trillion, you know? So scale is definitely one that for us is essential. The second one is re-regulation, deregulation, simplification, put it as you wish, but it was laid out very clearly in both the Draghi and in the Letta reports. We have so many levels of regulation. I think the Draghi report calculated that there are 270 regulators in Europe regulating digital networks. This cannot be possible, and it doesn't look like a single market. Let's sit down, decide which rules are essential, and let's try to get rid a bit of the duplications, sector-specific versus horizontal rules, and also let's try to get rid of the duplications between the national and the European level. The last one is having a real industrial policy. And here I link back to what also Christina was saying. And in their industrial Eurostack, they have laid out the vision very clearly. This is about doing. And industrial policy for me means let's develop a common vision of where we want this sector to be. For the past 20 years, we asked from my sector, from telecoms, only one thing: keep the bill at the end of the month as cheap as possible. Price is low. Affordability is and will remain a crucial aspect politically, but also from the societal viewpoint. So that's not gonna go away. But we cannot ask from an industry that today we are told is critical for defense, for security, for competitiveness. We cannot ask them or set them as a policy just to deliver low prices. Because if we are setting them just to deliver low prices and we define our citizens only as consumers, then we are forgetting about everything else. We are forgetting about giving 5G standalone to the industrial complexes, which means that maybe a European steel or car manufacturer is 5 years behind on the type of connectivity we have compared to a Chinese or to an American one. Then we are not asking them to do it as secure as possible and to keep this communication as secure, as trusted as possible. And we are not doing a whole series of other things that are equally, if not more important in the current historical, geopolitical, and socioeconomic context. So if I conclude, I hope that what we can see as telecom operators is to develop together a new vision for the sector that has a bias for growth, for action, for commercial action, so that in 10 years we can turn back and say, okay, we are leading in edge cloud, we are leading in 5G standalone, instead of doing what we are doing today, which is turning back and saying, oops, we lost the consumer internet to the Americans. Oops, we lost the smartphone revolution to the American and to the Chinese. Oops, we lost the app economy. What we need to do now, seizing the good ideas of the Draghi and the Letta report, is to put them in concrete action, go beyond the resistance of the status quo, which you will find in our industry, you will find it with regulators, you will find it with ministers, you will find it also inside the Commission. But if you wish, it's a bit of a fight for survival, not for one sector, as Marzia said, but for one infrastructure that is the infrastructure for the next 20 years. If at the beginning of the previous century, you had to build the roads and energy lines to imagine the growth of your country, today you continue building those infrastructure, but you need to build the resilient and advanced digital infrastructure. That's the one that is gonna feed your children in the 2030s and the 2040s. That's how you imagine a future for your society.
Alessandro. I have actually other questions for you, but I think it's better to leave the discussion to the audience. So please, if you want to ask questions to our panelists, you can. Anyone want to start? No one? Otherwise, okay, Nicola, go ahead. Can you give the microphone, please?
Maybe it's a small issue just to break the ice. As regards wholesale regulation, given the situation in Italy of FiberCop, do you think that it's already the time to do something in that regard? I mean, we are a near monopoly situation, so we need to regulate. I know that, I'm an advocate for light regulation, no regulation, ex post regulation, but the fact of having something like the old monopoly could be a risk of not having enough investments in the fixed networks, in the infrastructure, at least in the sense of monitoring performance. I repeat, it's both against the wind in the sense that you are advocating for less regulation, and it's maybe a small and particular issue. Still, I believe that this might be an issue, at least for Italy and also for NetCo, ServCo models, if we go towards a single NetCo provider. Thanks.
I don't know, Marzia or Alessandro? Okay. Alessandro, want to say anything on this?
I can
regulating, I mean, if you separate the network and you do that on a more general scale at European level, of course, you know, the point of having wholesalers that are kind of monopolists on their markets can create the problem of guaranteeing the level of investments in the infrastructure. This is a general problem that have been also mentioned to me by several people trying to say, well, look, I'm not sure that going in the direction of separating network and services is a good idea. This is kind of you know, easy argument that is typically used in this case. How do you see the possibility of continuing to invest in the infrastructure even if you change the shape of the market?
So let me give you a response based on what today the Electronic Communications Code foresees. the Electronic Communications Codes today foresees that wholesale only is deregulated on the basis that when you do a separation of the service and the network, then the incentive of the wholesale only is to sell to everybody on equal grounds. And so the old SMP model that justifies regulation ceases to have a reason, because basically the new wholesale only company cannot favor one over the other. And that's why in the code in 2018, they put this incentive to go to the wholesale only. They basically told to our sector, if you go there, you can get deregulated. The other case of partial deregulation, less intense than the one that the wholesale only should be able to get, was the co-investment, meaning you get different players in the market to co-invest with you in fiber, and therefore you justify deregulation. But the really deregulated model in the code is the one that is wholesale only. But what I want to say, because we will need to see now, there is a specific market situation, and as Connect Europe, I'm not going to comment on one specific market. We look at Europe and at the European rules. But let me say one thing. The reason why many people have considered or are considering the wholesale-only model is because the other models are too regulated and they didn't give you the incentives for fiber, right? For investing in fiber. Because the hope of the market is to reason more in commercial terms, like other markets, instead of having regulated wholesale prices, to have commercial terms for doing that. So regulation is one of the reasons that led to create market incentives for wholesale-only companies, including into the Italian market, because otherwise you are very highly regulated. So you see, it's a bit of a chicken and egg.
No, but I'm not concerned about, sorry for interrupting you, I'm not concerned about the fact that the wholesale operator is going to favor one or the other. I'm concerned about the level of investments in the infrastructure long term.
Yeah. I understand that concern. I don't know the specifics of the investment plans. Our system until now was based on the idea of infrastructure competition, but it was thought of for a period in which the investment of infrastructure was of a different magnitude. Now, the strategic question is, how fast can we get to find money, basically to have a full fiber situation. And right now we didn't crack that equation, because I saw that last week the Commission presented their State of the Digital Decade report. The target for fiber will be reached in 2051, 2051. So very down the line, because the issue is that fiber costs a lot and you need a return of investment. And our regulation today is not designed to think of the return of investment, but only to think of competitive incentives in the market and in the end, what is the effect on retail prices. It's not geared towards thinking, is the equation between weighted average cost of capital and return of capital employed the good one? Because we know that today the return of investment in most European markets is lower than the cost of capital. So it's a bit of a broken equation. And so I don't know what will happen in Italy, but the system that we had until now brought also to the situation in which Italy had to create a wholesale only.
And then I'm even more worried if the ROI is in such situation. Who is going to invest on the infrastructure or the wholesale operator? Okay, thank you in any case. Bye.
Continue with a question for Cristina and Tullio, right? You presented two different perspectives that can be aligned in the terms of creating a single market, but at the same line, regaining competitiveness in the digital services, putting together the companies, right? Tullio mentioned that one of the big resistances for these changes in the member states, they don't want to give out the portions of their sovereignty. But on the other side, I heard also some opinions by market players that are not completely aligned in the direction of seeing a real advantage in the single market on one side. If this is the case, how can we really convince them to a big initiative like the Eurostack? How can we really align the different point of views of a large set of market players in order to have a big initiative for the single market and for creating a European platform for digital services?
Does Tullio want to start?
Cristina, go first.
So, just to be clear, I very much support what Tullio is saying in terms of the need to create a single market. It is, of course, one of the things that we need to work towards. I have seen in the last 9 months, since the Eurostack initiative really took off, an incredible development in that direction. We have a discussion on digital sovereignty, which is maturing in a number of member states, not necessarily just in Brussels. We have France, which is very sophisticated, always has been, to be fair, around the issue of sovereignty. Politically, it is very popular. But Germany is certainly moving in that direction. We have seen the concept of Eurostack being written into the program of the coalition government. We have the Netherlands, which has made moves in that direction. Denmark has publicly declared that the public administration was no longer going to be just purchasing Microsoft. We have Eastern European countries like Poland that are moving in that direction, and even Sweden, which had been an arch pro-American supporter and not favorable to this vision, has very recently stated that we need to do something to reduce our dependencies. So I think that the push from industry, really, which is moving in a very strong way in this direction, has very much motivated politicians to listen, because the reality is that politicians don't listen to think tanks and civil society that much. It's interesting mood music. They move and they listen when capital is speaking. And that is why I put a lot of emphasis around the role that industry needs to play, because only if industry plays and indicates what the way forward is, we can expect support from politicians. Now, I do not think that this is an issue that is resolved, as I said, by showering money from Brussels. This is where we need investment. It is also the case, just to be clear, that I'm not a lobbyist from industry. I'm not paid by anyone. I don't get a cent from anyone to say what I say. So I'm saying it out of personal conviction. But having worked in industry for a very long time, I know that in the political arena begins to listen when industry really points the way. We cannot rely on the politicians or the bureaucrats to make a plan. That is doomed to failure.
Thank you, Cristina. Very clear, very interesting. Unfortunately, Italy is not in the list that you made.
No, Italy is not in the list, and it is a real problem. Italy is fanalino di coda, come ci diciamo tra di noi.
Yes. Tullio, go ahead.
Completely agree with Cristina. That is the problem. Absolutely, we need industry on board, and we need the industry to lead the process. As I was saying at the beginning, as it happened with the creation of the single market. I mean, it wasn't just bureaucrats in Brussels. On the contrary, it were in particular leaders in the industry who brought forward the process. And I think that this explains also, and I think that everyone said this, that we need a European strategy, a European industrial strategy, sorry. It's a broader issue. So it's not only related to telecom, it's not only related to one sector. It's in general 10 years, 20 years of crisis, of evolution that are leading us to navigate this new tension between, on one hand, the economic approach on which we base the European Union, on which we base the single market, pro-competition, and this new need that we have, a need for defense, a need for strategic autonomy, and the interaction between these two elements that are on the opposite side, of course, of the spectrum is exactly where we are now. And this means at the end of the day, we need a new industrial strategy, industrial policy, we can call it like we want. This, of course, does not mean going back to using instruments we had on the past. And I agree with Christina, this doesn't mean like only throwing money from the European Commission, from Brussels in the industry. It means putting all these elements together. Also, regulation that was mentioned. Regulation needs to be matched by a specific vision for the future of industry. And when we talk about telecoms, Alessandro, is true. The focus was only on low retail prices. And of course, we're happy with this. I'm pretty happy with this. I pay a good price. I have a very good service. But the risk we are facing today is that in the long term, if we continue like this, macroeconomic trends tell us that our market, our telecom market, as in many other markets, will be dominated by foreign companies, so foreign interests, that at the end of the day will come and set their own rules, their own standards, and eventually also their own prices. So developing this European industrial strategy together is the priority. Of course, it's very difficult. There are a lot of political hurdles, but it must be, and I agree again with Christina, a process that has to be done together with the industry. I believe that also universities, think tanks can play a crucial role. It's about building coalitions. It's about doing things together, and I think that really that is the problem we're facing today.
Very well. Thank you very much to our panelists. I think we had a very interesting discussion, and I can say that our community, national community of telecommunications, is really aligned and can help in pursuing these goals. So let's try together to find the right venues where raise our voice and try to change the situation and put Italy also in the list. Thank you very much. Great. So thank you. So we continue with the program. The next session will be chaired by Ilenia Tinirella. So Ilenia, please.
Good afternoon. So we are very pleased to move to the next session. This will be a more technical session in which we will introduce some technical demonstrations. So let's start with the first one because we are slightly late. The first one will be presented by Mattia Lecci from Keysight Technologies. It will be a demonstration about a self-free massive MIMO experimental proof of concept platform. So, Mattia. Ok, ti segnali ok?
Non c'è un timer.
Okay, so hi everybody. I'm Mattia. I'm working for Keysight Technologies and specifically for the 60 program in Keysight Technologies. The company is a test and measurement company. So in our portfolio, we have lots of different components from oscilloscopes, signal generators, signal analyzers, but also test equipment for UEs, GMBs, and different parts of the network. Also electronic components, fiber, antennas, or really anything. The 6G program specifically is a group of mostly researchers. We collaborate with universities, research centers, and other R&Ds from different companies. And we try to either advance the state of the art or make it so that our instrument can advance the state of the art. Today I will talk mostly about the project that we are doing here within the 6G-YNet. It's based on cell-free massive MIMO. So for those of you who are not familiar with it, I will give a very brief explanation at the beginning. And we basically created this experimental platform that we're using here. So what is cell-free massive MIMO? So you all know that historically networks have been, mobile networks has been focused on cellular networks where the base stations are the key component and UEs attached to these base stations. And then when there's mobility, they go around, they hand over to a different cell in case that has to happen. And you know that there are issues in the cell edges with interference and with the lower performance. So the idea from researchers lately has been, well, for a few years actually, has been to remove the cell concept and move to cell-free. So the UE is the center of the network, and APs or access points are just serving UEs in a user-centric manner. So they provide signal to the UEs. So these, in theory, should allow a more uniform service quality, but also some macro diversity and remove the need for handovers. So these are some pros, but what are the cons? You can imagine that, of course, at the physical layer, you have to synchronize multiple APs so that they interfere with each other and create a good signal for the specific UE. So that it has to be very, very well synchronized down to the microsecond level. CSI acquisition can be pretty problematic. Then there is the issue with precoding, with combining, power control, but even the coordination, right? You have UEs moving, so you have to select which of those APs will serve the user. Or there are many different ways of doing this, right? So depending also on your architecture, you might need higher capacity requirement for the front hole or the back hole or the mid hole. And deployment as well, of course, you need sort of a densification of the network if you want to use multiple APs to serve a single UE. And the operator, which I believe are in this room, know that densifying the network is not really cost effective. So that's a bit complicated to be done. And standardization right now is at 0. It's right now still mostly academic, and industry is starting to look into it. So there is no standardization being done at the moment. Use cases of this, well, as I said, densification is an issue, so definitely not urban scenarios at the beginning. So most likely, if it will ever start, it will probably start from more controlled environments like stadiums, shopping malls, or smart factories or stuff like that. So how do you test this, right? You have UEs moving, they need to maintain sort of a consistent channel. So ray tracing comes to mind. So we do have, for example, our own software doing that, RaySim, right? So you can sort of import a 3D map of whatever you're interested into. In this case, you see an urban environment, but you can also do other 3D maps. So you compute the channel by placing base stations around. You can put UEs around. You compute the channel, and then you import that channel into a channel emulator. In this case, the box on the bottom right, it's called PropSim. And that allows you to do real-time RF channel modeling. And then you can really put radios on top of it. So it's really an experimental testbed for this. So again, RaySim started with the idea of urban scenarios in mind, talking also to the developers, and we are also trying to include genetic 3D models into it. And so you can see on the right, a stadium can also be sort of imported, and you can do simulations there. It supports mobility and many UEs and many base stations at the same time. So how do we do our tests, right? So what is the workflow that we use for our tests? Well, you first start, as I said, with RaySim. So you design a propagation scenario, right? You run the simulation, and then you export the simulation and import it into PropSim, which is the actual RF channel emulator. So ray tracing is done offline, and then the output of that is imported into the channel emulator. On the other hand, to make it more realistic, right, we're not using whatever kind of signal, we're using 5G waveform signals. So we have software that allows us to design standard-based waveforms, and we are trying to make it so it's compatible with this self-free massive MIMO architecture. So you create this unprecoded waveform based on standard 5G signals. You load it into MTRX. MTRX is another big box that acts as a transceiver. So it has, you can select some ports to transmit the waveform, in this case, a playback of the waveform, and you can select some other ports to receive the waveform, and in this case, specifically record the waveform on a file which can be later processed. So what you do is you transmit the signal to MTRX from the base station side, you propagate the channel through PropSim, and then you record it back into MTRX, and then you have waveform files recorded at the receiver. Then we have some software, System View again, that implements the 5G receiver, is able to do the full, physical layer computation. So it's able to estimate the channel, do the precoding that we want. We can select whatever precoder algorithm that we want, and then it precodes the waveform. We pass it through MTRX and PropSim again, and now we finally have the output of the precoded waveform. With that, of course, we can run some analysis. We can do it with System View. We can do it with VSA. It's another software that allows us to see what are the results. And of course, all of this is pretty cumbersome to do. So we have automated the whole thing thanks to pathway test estimation, which allows us to orchestrate all the software and hardware components nicely. And so you basically set up a few parameters, you press play, and after a while you get the result on the other side. And so you can do some simulation campaigns and get some data and do plots and so on. It's important to say that this is not something that we started with Sparks, but it's actually leveraging a prior work done in another project called 36G, but we are expanding that in Sparks in 6G YNet. So an example of the results, I will just show you a trailer, let's say, because you will also find me later in the demo booth. I will show you something more if you're more interested into this. Of course, we're not dealing with the stadium, right? We are doing something very, very simple. When you go to hardware, you have to simplify a lot things. And in this case, specifically, we are using 2 access points, each of them with 4 antennas and a single UE with 1 antenna. And so you can see what happens on the right side, where both AP do joint precoding towards the UE, and what happens when only one of the AP does the precoding by itself towards the UE. AP1 on the top is barely visible. This is a 16-QAM signal. And you can see in the AP2, you cannot see basically even the constellation there. So it's pretty hard to get any result there. So to conclude, again, this is just a trailer. So if you want if you want more information, just ask me questions, or you will also find me in the demo booth later. But to conclude, self-free massive MIMO is a state-of-the-art mobile architecture. It's still under very intense research, and it's actually one of the hot topics now for future networks. It's quite well understood, I would say, from a theoretical standpoint, although there are some things that still need to be studied. There is a very good amount of simulated results, because typically you will find analytical results and simulated results in papers. But looking at the state of the art, there are very few experimental setups. So that also means that there is no standardization done, because in practice, it's really hard to find real results. And so what we've done here was proposing this experimental setup with hardware in the loop, where we have this realistic propagation environment with RaySim, and we do this realistic physical layers testing. Again, if you have any information, you can see my email there, or you can ask them now or later in the demo booth.
Okay, just a quick question. Thanks for your interesting presentation. I think it's promising to see the hardware in the loop together with this realistic propagation environment. So I was curious to know if this propagation environment is available for other researchers of the program, or I don't know if you have within the Restart program?
Not really, not that I know. At least it has actually been launched in the Mobile World Congress in February 2025. I think the official release in last week or this week or soon. So I don't think anybody has access to it other than some very few initial collaborators. But yeah, that's probably a possibility.
So in case we are interested, we can contact...
You can contact me and then I will find the right people to talk to.
Okay, thank you. Other questions? Okay, if not, thanks again, Mattia. We move to the next presentation. So we have again a demo-oriented presentation. We talk about photonics now. So applications for radio functionalities, and the speaker is Antonio Malacarne from CNIT.
Good afternoon, everyone. So my name is Antonio Malacarne from CNIT in Pisa, and this is a presentation about the proof of concept number 3 coming out from the Rigoletto structural project coordinated by Spoke One. And this is a synergy between Sant'Anna School, CNIT, and Ericsson Research, all of us in Pisa, located in Pisa. So I generally skip this type of slide, but today I think is useful because this is going to be a hybrid presentation. So I'm going to give some background motivations and describing the application scenario with slides. Then through offline videos, I'm going to show the photonic integrated circuit we realized for our optical local oscillator for performing our 100 gigahertz radio transmission system. And then we will connect with the Pisa's laboratory to show you the system, the operating system, the radio transmission system, thanks to a colleague that is there. And then giving some performance with additional slides. So we are talking about generation of millimeter wave frequencies through photonics. This is because even right now, some frequencies approaching 70 gigahertz and beyond are already planned to be used for 5G new radio. In automotive, this is already a standard between 77 and 81 gigahertz. And very soon, with 6G new radio standards coming out, we foresee the utilization of frequencies up to 100, 110 gigahertz, and bandwidth occupation up to several gigahertz. So we know that several sub-bands in the W band, which is the band between 75 and 110 gigahertz, are already likely licensed for wireless and satellite communications. And also the quite recent hot topic of the joint communication and sensing. So using the same hardware for communication and sensing, it's already under study with hardware at 60 gigahertz and also up to the sub-terahertz range. So we have plenty of motivations for this work. Our vision, together with the Ericsson Research, is to try to remotize as much as possible all the possible hardware to the base cabinet, so away from the remote antenna in a, let's say, a radio access network. So the two elements are connected together through optical fiber. So we want to create a signal in the optical domain that then can reach the antenna and eventually, after photodetection, be up-converted to the millimeter wave frequency. In addition, jumping to the millimeter wave, we also can get miniaturization of the antenna dimension. So the concept is quite easy. So we have... Is it the point? Yeah. We have our optical local oscillator that in our case is going to be achieved through a photonic integrated circuit in silicon, which generates an optical spectrum with phase-locked optical tones, which are spaced by the frequency we want to achieve after up-conversion. Then this is followed by electro-optical modulation stage, where we load our intermediate frequency data signal. And then this signal can be delivered to a remote antenna where the photodetector is. In the end, we get, after the photodetection, our up-converted signal at FRF plus or minus intermediate frequency. So the complete proof of concept in our lab is divided in two laboratories. One is at the ground floor, where we have our photonic integrated circuit under test, because we realized a first version of this device that was fully optoelectronically packaged, but then we decided to use a more efficient architecture, as I'm going to show you in the next slide, I guess. So this device then delivered through optical fibers in the building the signal from the ground to the first floor laboratory, where we implement all the rest of the test bed, so modulation, photodetection, transmission between two W-band antennas, down conversion that currently is implemented through a commercial down converter, and then acquisition of the signal and reconstruction. As I said, during the project, we developed a first version of the optical local oscillator, which was this interferometric structure. So we have a laser, we split it. On one arm, we generate optical frequency comb driven by a lower frequency local oscillator, in our case, 20 gigahertz, around 20 gigahertz. And then by selecting one of the comb modes through an integrated tunable optical filter, and coupling it back with the original laser mode, we are able to basically multiply the local oscillator frequency by a factor that can be 4, 5, 6, so up to the millimeter wave band. The limitation in this case was that this architecture led to some thermal fluctuations of the filter impacting the phase noise at the low, the tuning frequency offset range. And also it limits the performance in the high frequency offset range because of the limited SNR that is due to quite high optical losses. So we realized other architectures based on two filters, but again with more or less the same problems. In the end, a multiple resonance filter was designed. This is a distributed feedback resonator filter based on Bragg gratings in waveguides. I already talked about these structures in past plenary meetings, so now I'm not gonna enter into these details, but with a single filter now we are capable of select both harmonics out from the optical frequency comb. So we lose tunability of the solution, but this solution has lower optical losses, and the fluctuations given in the two pulse bands are more or less correlated. So this way, after photodetection, through the beating of the two modes, we cancel out this contribution. In the end, the phase noise performance are identical to an ideal frequency multiplier. So we employed this solution, and we don't have the package solution yet. So this is on a micropositioning stage in this ground floor laboratory. Here you can see on the left the dual resonance, the FBR filter response. And in the center, you can see the output. So this is the spectrum coming out from the peak, from the photonic integrated circuit. So here on the left, you can see a offline video of the setup we employed for the peak characterization and testing, and then we are currently using it. So you can see there are DC multi-probes, RF GSG probe, the fiber array for connecting with, this is a microscope image of the circuit. And then, okay, here you can also see the filter spectral response. And then on the right is just to show you that it's possible to tune the shape and the frequency of the filter by acting on the micro heaters in each phase shifting section along this cascade, the Fabry-Perot structure. So here you can see that starting from a tilted spectral response, we can act on a micro heater to tune it, to shape it in order to get flatter and symmetric with respect to the frequency domain. Again, here on the left, there is a video just showing the thermal stability of the peak we are capable to achieve with this number that you can read here, so plus minus 0.002 Celsius degrees. And on the right, you can see the output of the circuit. So this part is offline. Now we should connect with Alberto Montanaro, who is in Pisa, and is going to show you the rest of the test bed.
Hi.
Hi, Alberto. Can you hear me?
Yes. Can you hear me?
Okay, so yeah, we see and we hear very well. So give us maybe an overview of the two antennas first,
Yes.
and then.
So this is the setup that Antonio has described. So here we have, let's say, the transmitting part, where we have the antenna that is fed with a photodiode. The photodiode takes the two lines of the local oscillator, as you can see here. So this is the optical local oscillator, spaced more or less about 100 gigahertz, specifically 93 gigahertz. And then this local oscillator is modulated with the modulator and fed to the photodetector that you can see here. So the detector then is connected to an antenna that transmits the signal that runs up to here. And then this is, let's say, down converted back to an IF frequency of around 5 gigahertz. And the result, so the transmitted OFDM signal is here. These are OFDM signals that are, let's say, uncommon. These signals do not follow a precise standard in the sense that we have developed these high bandwidth OFDM signals. As you can see here, this is, for example, at 100 gigahertz bandwidth. And well, I think that's it. I don't know, Antonio, if you want me to take.
No, thank you very much. Yeah, so this in particular, we're looking at our FDM signal with QPSK on subcarriers for a total information rate of 2 gigabit per second, I guess. And this tool was developed in-house, so we can basically generate any type of OFDM signals, and we have all the variables under control, and that can be changed and customized. And this testbed is actually available for anyone if you want to test, I don't know, a DSP for the detection, or some custom generation of the signal, or some alternative ways to up-convert and down-convert the signal in the way you prefer. So this is available for all the community of the project. So thank you, Alberto.
Thank you. Bye.
So in the end, here I summed up all the performance of the system. So we generated OFDM signals up to 3.5 gigabit per second with all bit error rates measured to be lower than a typical FEC threshold. And also single carrier QPSK and 16QM up to 4 gigabit per second with EVM performance in this case, because we used a tool for detecting the signal that was embedded into the real-time oscilloscope, and it provides EVM instead of bare, but I mean, it's basically the same. So this is pretty much all. Thank you for the attention.
Okay, thanks. Just a question from my side. Is there any alternative photonic integrated circuit comparable with your system on the shelf, or what is, in your opinion, the main contribution of your innovation in this?
Here, our focus was to generate this optical local oscillator with the millimeter wave frequency spacing between the modes. There are alternative ways, of course, generation of optical frequency comb in every way you can think about. So through microcombs, as Tobias Kippenberg's group used to do, or other alternative ways. This is a silicon solution, silicon-based solution, so with all the pros and cons that comes out from this. And I mean, it's hard to compare the performance because I don't think there are a lot of transmission experiments exploiting this type of. I mean, I can think about a couple of solutions. Another solution that we are also actually investigating is locking of two independent lasers. So with the PLL schemes or optical PLL schemes to phase lock two lasers together, that actually provides similar results, I would say, maybe lower phase noise performance, but higher optical power, because here, I mean, you have to take everything into account. Our target here was to optimize the phase noise performance. But then, of course, if you have to introduce optical amplification, electrical amplification, this also gives you some noise floor and noise limitations due by noise. So you have to put everything together, and we are investigating, for instance, both solutions. So maybe our solution is easier to be integrated, but yeah.
Thank you. So, other questions? If not, thanks again.
Thank you.
And let's move to the next talk. It will be given by Andrea from University of Ferrara, from Andrea Conti from University of Ferrara, and the title is Real-Time Tracking and Classification of Multiple Targets via Wireless Sensing.
Thank you. Thank you for the invitation. So I'm going to show you, hopefully in real time, a demo about tracking and classification of multiple targets via wireless sensing. This is a demo that has been developed within the TAPIN project. The TAPIN project is a cascade project of the 9th structural project, Industrial Networks, led by Roberto Verdone, and I am leading this cascade project that involves 3 universities and 4 companies, as you can see. The 2 projects really work with a high level of synergy and integration, and in fact, we've been not only joint meeting, but also we developed together 7 demonstrators that you can see in the demo booths over these 2 days, and the 6th one is the one that I'm going to show you in a moment. So why research activity and then proof of concept of wireless sensing? Because for a number of applications, but also for the control of the network, is very important to be able to track and identify, classify objects that might not even already be connected to the network. This is within the framework of wireless sensing, of course, and we want to do it using radio frequency for a number of reasons. There might be privacy concerns, or there might be a situation in which fog does not allow to use cameras. So we want to see how can we perform by tracking and classifying device-free target. And no need to say that integrated sensing and communication is a very hot topic and is in the agenda already of release 20 by 3GPP with technical specification and technical reports. So we develop a framework. A signal processing chain, basically, that aims to detect, track, and classify objects that are not connecting to the network by simply processing the samples of the received electromagnetic waves after reflection to the targets. Okay, and this is composed in offline phase and online phase. I'm not giving you details now because I want to give space to the real demo, which is happening in an industrial warehouse in Ferrara. But one aspect that I would like to say is that it's possible to extract information on the type of targets. For example, if it is a human or a robot, as we will see in an industrial setting, not only by using, let's say, classical techniques based on the radar cross-section, but also by exploiting some training, some knowledge on the movement. Okay, so looking at the Doppler map that they generate. Okay, so this is a video that I hope I don't have to show you because it means that the real demo works. So let's go to the. Okay, so let's go to the real demo. Davide, which is in this industrial warehouse in Ferrara, is now showing you the environment where we are. Okay, so this is an industrial warehouse. It's kind of tall and ugly with a lot of metal and a lot of reflection, all things that we don't like for the operation of the system, but we like for performing research and test. And in particular, within that area, we found, this is the radar. This is an off-the-shelf radar, MIMO radar, 16x2, operating at 77 gigahertz. That we just bought. We developed the signal processing chain on top of it. And this is the area that we pick for the demonstration, which is around 55 square meters. And you will see there, okay, so you will see here this square, blue square, which is 60 by 60 centimeter. I will use it to show you the accuracy of the system later. And you will see this area that we define as danger area, so that we want some flag or some alarm happening when the person entered this area, not when the robot entered this area, for example. Okay, so we can now share the, okay. Okay, so now we can start the demo. Alessandro is sharing now the map. This is on the left, the map that represents this environment. This is the radar, this is the table in the middle, this is the blue square, and this is the danger area. This is the range Doppler map, and this is the table with the coordinates in space, velocity, and the type. You will see that after 1.5 seconds of after detection of the target, you will see that it is going to be classified as human or robot. So Alessandro, you can start whenever you are ready. So you see that the person entered the environment. The person is now detected, is white, is evaluated, now is red. Here is written human. You see that is moving. Now a robot enter. It is also detected and evaluated as a robot. You see that the robot and the person cross each other, but the tracks are not lost. You see that the robot can go below the table. You see that the person is in the middle of the square. Now there is another person that entered the environment. No need to say that the smaller the environment, the harder it is. You see that the person entered the area and the flag happening. So now Alessandro is exiting, the person enter again the area and is exiting the area. Now I would like to ask Alessandro if he can enter again, just to show you the kind of accuracy. Remember that this blue square is 60 by 60 centimeter. So you can see that now he is on the corner, on the other corner, again on the corner, and now he's also moving, and is moving with different speed, different trajectory. We try to make the mobility model, we try to be challenging for any mobility model. So you see that now he's changing speed, is changing direction, and in fact, I think that in this specific moment we lost him. We didn't lose him earlier, but this is the real-time demo. So let's see again. Alessandro, can you please move? Thank you. Okay, so you see that he's changing direction fast, and the system is tracking him. Now Alessandro can exit. Okay, thank you for now, Alessandro. What is the kind of accuracy? We have an accuracy of below 1 meter in 98% of the time in tracking, and in classification around 92% of the time. Of course, it depends how long is your training. But for example, this demo has been built by training the movement of the robot in another environment and then putting it here. So this is a level of robustness that you want to check. We also integrated this data into a microservice architecture, because we have heard already about the disaggregation of the network, the importance of having data in a microservice architecture, localization as a service, but also wireless sensing as a service. And these data are going to enter into the digital twin the BB World is building, and that you have seen already in the demo booth of the industrial network project. And this is an example. Okay, so in conclusion, we have developed a real-time framework for detection, tracking, and identification of device-free target. This target can be human or robot in this example, but we can think also of other classes of target. We validated this research thanks to the STAR program using a MIMO radar operating in an industrial environment. And we are now integrating this in a microservice architecture with the scope of entering the data within a digital twin. And with this, this concludes the presentation. And if you allow me, since I have those three collaborators under 40 plus degrees in an industrial warehouse, I would like them to show under the camera, because it is their merit, of course. Those with gray hair speaks, but there are people, young people that within the STAR program have been working. Thank you.
Thank you. Let's thank our speaker. Thanks, Andrea. Very nice demonstration. Okay, questions, please.
If you don't have any information about a number of targets, how can you detect and separate them? So is that a problem, your algorithm, or not?
The information that we are putting is about the maximum number of targets.
Right. There is a kind of model order information or
yes.
something of the sort. Yeah.
Exactly.
Yeah. Thanks a lot.
Yes.
Maybe you said that, but can you give an estimation of the accuracy or the precision of your position?
Yes, with pleasure. So you have seen that blue square, which was 60 by 60 centimeter, and you were able to see if the person was on a corner, the other corner, in the center. So I would say the 20, 30 centimeter. We had also some long trial where we have seen that we are able to be sub-meter in 98% of the case for the tracking. In an environment like this, okay? Environment like this means that you have a lot of clutter, a lot of metal, but somehow of course your radar is in line of sight with the air, so it's with the monitor area. Okay.
According
the
to the
performance will
use,
decrease if you try to do something in no line of sight with the radar, because it is.
According to a potential user, do you think 20 centimeter is enough, or you should go below that figure?
We always try to do better, but for example, what could be the potential use, right? Potential use could be, for example, to predict the movement of certain possible user equipment in order to control the network before it happened, or for example, for safety situation in industrial environment. So for safety situation, I think 20 centimeters is okay. For the setting, for example, for beam tracking someone even before he connect to the network, I also think that order of accuracy for now is sufficiently accurate. Of course, it is not enough if you look at the service level requirement of 3GPP, but in that case, they are talking about active localization after the user equipment is already connected to the network.
Thank you.
Thank you.
Okay, so let's thank again our speaker. So let's move to the next presentation. It will be given by Simona Russotto from CNIT. And the title is Digital Twins in Action, Optimizing Access and Core Networks with the Coherent Platform. Okay.
Good afternoon, everyone. Let me introduce you myself. I am Simona Rossitto. I am a researcher at CNIT Collab in Catania. And today I will present a work carried out in the Coherent project that is called Digital Twin in Action, Optimizing Access and Core Networks with Coherent Platform through a streaming video in 4K definition. So let's start to introduce the partner involved in the project. At the left part of this slide, you can see the initial partner involved in the project. By other cascade call, in the other column of this slide, you can see the other partner that joined the project. So as you can see, there are both technological and industrial partners, and then and also academic partner that collaborate together to develop the demo that I will present today. So what is the main goal of the Coherent project? It is to create an open architecture for every telecommunication network, but the principal argument is the use of the digital twin that is able to real-time monitoring, simulation, and optimization. To do that and to demonstrate this architecture, we develop a demo that I will present today related to a real-time 4K video streaming optimization. And in the meanwhile, we develop also two proof of concept, one related to the energy efficiency in 5G mobile network, and the other to the energy consumption optimization in fixed access broadband network. So let's present a little brief overview of the Coherent platform structure. It is based on a microservices system. As you can see, there are two main parts. The cloud part that you can see at the top of this picture, and the edge part that you can see at the bottom of this picture. The cloud part is developed in Kubernetes, while the edge part is developed on Kubeage. In the cloud part, there are 5 main namespaces. The two at the top are NS Basic and NSDT that are related to the ontology and the semantic of the representation of the digital twin. We have chosen the asset administration shell standard and the basics framework to do that. Another important namespace is the namespaces controller that is related to the activate, deactivate, and eliminate, and the social of the digital twin, but also on the platform and orchestration and optimization of the platform. Another important namespace is that you can see on the right of this picture is related to the intent. There is the intent mapping model that receives the intent and processes it, and there are also other important blocks like SLA model to respect the service level agreement, and then the analytics and service orchestrator that process the data and make and output the real configuration. Then at the bottom, as I previously said, there is the edge component that is important because it's the bridge to the between the physical asset to the digital twin. It is implemented using the data bridge component of the asset administration shell standard that use MQTT protocol to make the communication between physical asset and digital twin and vice versa. So let's dive into the real core of this presentation, that is the demo, and we can see on this diagram the emulated network topology. We have 8 open flow switches and 2 hosts, a server and client. At time 0, the ONOS controller chooses the shortest path, represented by the blue arrow, and it is a low bandwidth link. After we start the Coherent platform, output a much longer path because there is one switch plus, and it is represented by the red arrow, but it is an increase of the bandwidth of the streaming video. We have here the digital twin of the entire network topology in ONOS, but it is possible to have the digital twin of each device is inside the network. So at time 0, the first step is to start the Mininet, the network topology in Mininet, and as you can see on the bottom, there is the display of the network inside the ONOS controller. In the video above, there is the mapper, that is the main component of the edge part that collect the data from the real asset and send it to the digital twin. In the video below, there is the asset administration UI GUI, and they are displayed the configuration that are sent to the digital twin. We can see host, some other information about the link, the port set, and so on. At time 0, the video streaming, as you can see, it is displayed in low quality. So let's wait a little bit to see it. As you can see, it's low quality. After we start the coherent platform, we can see in the video above, there is the intent management dashboard. We have a lot of intent. We can create it with also natural language model, and we send our intent. In this case, is netflix 4K. That is related at some KPI like high definition. So in the video below, there is the service orchestrator and optimizer that receive the intent, choose the portion of the network infrastructure related to the intent, and collect the data, the configuration data from the digital twin inside the network chosen. Then, after some process of made by the analytics, it generates another flow rule that is sent to the other part of the architecture. The orchestrator send the flow rule at the active part of each digital twin, and you can see in the video above. While in the video below, the active part send this configuration to the related mapper, and the mapper send it to the physical asset. So in the next video, you can see that when the rule is added on the physical asset, the quality of the video increases, and we have realized the intent that we have sent before. So in conclusion, we have demonstrated the coherent platform is able to optimize network performance, and we say that not only in this simple case, but it can be utilized in much difficult case, like as we has already developed the two proof of concept related to the 5G mobile network and the fixed access broadband network. Thank you for attention.
Thanks, Simona. Questions? So I have a curiosity. So you mentioned that you first define a general intent at very high level, even in natural language. Yes. So how is it possible to map this high level intent into an optimization policies for the orchestrator? Which kind of intelligence are you
inside the optimizer?
Deploying?
There are some analytics like game theory and also artificial intelligence that map the intent with the network infrastructure that there are inside, that are chosen by the intent. So after collecting the data from the digital twin, the optimizer make some other process and generate the rule.
Okay. Other questions? Okay, so if not, thanks again, Simona.
Thank you.
Let's move to the next and last talk of the session that will be given by Antonella Poce from University of Rome Tor Vergata. And the demonstration is titled Innovative Telecommunication Solutions for the Enhancement and Cultural Heritage Experience.
Thank you. So, I think you should. Okay, so I'll start and try to be brief. We change a little bit perspective, because here we tried to support the communication of innovative telecommunication solutions for the enhancement of cultural heritage experience in the Tor Vergata area. Where is our work set? It is set in the net for future. The goal, as you might remember, is to harmonize restart outcomes to turn emerging social goals into technological solutions for future telecommunication networks. And of course, we took care of the social and cultural inclusion aspects, the well-being of users and community, and the development of soft skills, active citizenship, and cultural expression. Of course, we focus on the alignment of the vision, of the synergies, of user perspective, of shared tools, through, as you will see, a series of activities that were communicated through different settings, online and in person, thanks to the 5G technology that has been set in the Tor Vergata area, engineering area, and thanks to a virtual platform. We had 11 upper secondary schools participating from the area of Roma and Latina. We also cooperated with the Academy of Arts and Technology, and I'll tell you more about that. And we involved in this part of the work more than 400 students from the secondary school I mentioned, 51% females, 49 males, and around 6% not Italian students. We worked on digitization and 3D reproduction of artifacts. We created a graphic novel. I will tell you in a minute more about that. We organized virtual tours through immersive virtual reality platform. We worked on object-based learning in virtual environments, of course, communicating a series of technical aspects related to how to create and use object-based learning, digital object-based learning, 3D digital object-based learning, actually. We also worked with haptic support, so tactile exploration of digital models, and we worked with touchscreen exploration of artwork reproductions, and we worked also a comparison helping the users to understand which were the artifacts created through artificial intelligence and which were the real ones, actually. So a brief, very brief video of the graphic novel that is the narrative engine.
Welcome to the presentation of Restart to the Future, a manga series in which real scientific innovation becomes the key to solving gripping detective stories. The stories will be told starting from an action taking place in a university newsroom called Who Said It, where a group of researchers have organized to tell gripping stories that happened on campus. 3 chapters of the story have been produced to promote Restart project solutions and are communicated through graphic novel techniques. The 5 protagonists are inspired by real researchers from Tor Vergata who have entered the world's top 2% of scientists. In the first episode, an ancient tomb is explored to rescue an archaeologist researcher and is successful thanks to the use of the 5G antenna installed on the roof of the engineering building and the robot dog named Spot. The comics can be experienced through the totems installed in the university engineering area, together with a virtual museum within which the story will continue in an interactive way and through 3D avatars built on the characters from the graphic novel itself. Thank you for your attention.
So this is the preamble, let's say so, where the story starts, and through the characters, the different situations that I told you about were told. We can go on with the second one.
Welcome to the presentation of Restart to the Future.
No, this is again, where you see what we actually did with the students in the Tor Vergata area. The music is not playing, but anyway. This is the area where the totems were put. We had also the possibility of install artistic works by a famous national and international well-known artist in the totems. The use of the haptic gloves, the virtualization software, the graphic novel, of course, where the stories were told, the digital objects, and that was the part introducing and showing what we have been doing. And in this video, you see the virtual museum that was, of course, transferred through the totems and through the activities that we have seen in the first video, and a short, very, very short showing of how to use the haptic glove with the 3D digitalized objects from the heritage of the area. The story told is, as I said, introduced by the narrative device of the researchers working on the case of the lost archaeologist, and then you'll see what happens.
Hi, I'm Sabina, the archaeologist who will guide you through this virtual museum. We will explore Rome and its surroundings, examining examples of homes both within the Eternal City and beyond. This will give us a glimpse into the lives of the ancient Romans. Let's begin our journey. The prestige of the Roman nobles was evident not only in their homes but also in their clothing and accessories. During excavations, archaeologists sometimes discover fibulae used to fasten togas, as well as remains of sandals, necklaces, and bracelets, like the ones displayed here. Men would also adorn themselves with ornaments, particularly for special occasions, such as sacrifices to the gods. These rituals often involved offering gifts using a patera, a type of cup with a wide, shallow basin, like the one I am showing you. Imagine being in one of the most beautiful villages in Italy, Sperlonga, just a few steps from the sea. Nestled among the green hills and near the end of the city beach lies the villa of Emperor Tiberius. This villa, dating back to the 1st century AD, is an extraordinary archaeological site, rich in artifacts and uniquely charming. It features a cave partially submerged by the sea, which once housed a fish pond, an artificial islet that served as a summer dining room, famous sculptural groups, and much more. The villa is located beneath a spur of rock. According to two ancient historians, during a banquet in the cave, a boulder fell from the rock above, crushing 3 slaves. Miraculously, Tiberius was saved by the courageous act of Sejanus, who shielded him with his body, thus gaining even more prestige in the eyes of the emperor. Was Sejanus, a prefect to whom the emperor had already delegated many powers, genuinely altruistic and brave, or was he simply a quick and calculating strategist? Regardless, Tiberius viewed the incident as a bad omen and decided to move to a different residence.
This is the experience with the gloves. So at a certain point in the virtual museum, you go and you can enter this room where through the visors and the gloves, you can actually touch the objects that Sabina, the archaeologist, tells us about. These are real artifacts from the area, of course, of Rome and Lazio. and normally found in ancient Rome villas, and in particular in ancient Rome noble women tombs. So these are, in particular, this object is a vase containing perfumes to be used by noble women. And the lucerna as well is another artifact that is normally found in this kind of settings. So as you can see, and tomorrow actually in our demo you can try yourself with the MetaQuest visors and the gloves how to handle the objects, feeling also the texture, the heat, and the temperature of the objects. What did we do? Of course, we for each activity we produced some testing in order to understand which was in a actually short time, but not that short. I mean, we worked through March and May with the students to understand which was their performance, in particular in understanding the grand challenges contents. One session of the module the students had to carry out with us, so not only the virtual experiences, was devoted to their understanding of the grand challenges. They had the possibility to access in the platform, in the virtual platform, to access the videos telling about the grand challenges. So a test was administered to assess students' understanding of content. And as you can see, 45% out of 400, of course, misinterpreted technical questions, highlighting some difficulties with concepts such as radio waves, high frequency, detecting deep fakes. Conversely, questions with a descriptive focus or based on practical examples had correct response rate exceeding 70%. Indicating a higher effectiveness of narrative applied content. So this is something that is interesting. I think we can reflect on that in order to support communication in certain areas. Another area we tested is the well-being level of the users while accessing the tools. We used a test that is, of course, published, the UCL test for well-being, the so-called well-being umbrellas, that you can see showed a fairly positive result. In fact, users show a fairly high positive emotional dimension, and the negative dimensions got low marks. So this means it was a good experience that they had as far as well-being is concerned. Well-being is an important dimension, especially in the education context, and it helps a lot to have better performances in education, in teaching and learning. The interest in the program was fairly high, because as you can see, very much and quite a bit were the most chosen answers. Only 15% reported little or no interest in the program we proposed to the students. The areas of interest of the students, this is an important result, I think. because 56% of the sample showed actually stated that they use normally generative artificial intelligence tools. And this was fairly impressive, actually. We had quite, among the 400 secondary school students, we had, a distribution mostly equal between the three different levels, third, fourth, and fifth year of the secondary school. Most of the students were from scientific secondary school, but we had also arts school, one art school, and one and different professional schools. Virtual reality also shows strong engagement, and 31% respondents reported the use of such tools. In contrast, augmented reality has been explored only by 10%. Again, there's the need to work on telecommunication to let students know more about that. Where is the interest based? Which technological field are you most interested in for your future? Most popular area are artificial intelligence and machine learning, virtual and augmented reality, software development and programming was chosen by 16% of the sample, cybersecurity and data protection only 10%. We need to work on telecommunication and digital networks. Of course, after this kind of activity, at least they know more about the area. So, a very, very quick overview of some of the findings. We had many different areas that were explored. So I think that at the final conference, we will have more data to be shown and some reflections that we can make. There are some publications that we carried out within the group. I thank you so much. I thank also the young researchers that are there in the audience and that really supported and made all this huge activity possible. Thank you so much.
Thanks. Thanks, Antonella, for bringing the user perspective and also, for showing some potential applications of our technologies that can have a societal impact for cultural heritage or even for education. So really thanks. Questions, curiosities about the study? And in any case, as Antonella mentioned, tomorrow and we have the possibility to really experiment in the project areas, both the globes and the device.
And of course, the virtual museum and the graphic novel as well. That is as I said, the storytelling device that we use to engage more the users. Moreover, we had also an artistic contest, and we actually had the possibility to make the second artistic installation in the engineering area. And the contest was, again, a way to engage the students from secondary schools to be an active part also from this point of view to work with the technology, but different kind of technology, from pencil to 3D models and telecommunication and 5Gs.
Okay.
Thank you. And tomorrow, of course, we are here to answer any question.
Okay, so thanks again. And this closes our session, and I think that now it's time for the break. But let's see what the boss is saying.
Thank you. So we don't have now the industry pitches session, so we can move directly to the coffee break for your happiness. And right after we have the second session for the exhibition area of the project. So again, I invite you not to leave after the coffee break, but please go and visit the booths of the project. Thank you. Tomorrow morning, we will start at 9 sharp, so please be here at 9. Thank you.